All right, in this video, I'm going to show you how we can make a wheel. All right, we're going to make all the little individual spokes and then the ring of the wheel, put a little sphere over here, and then we're going to eventually rotate it. Now, I know that in Trinket here, I have code all written out for you, but I think it's kind of helpful to kind of see how things are built. And I would recommend that you try to do it yourself. If you get stuck, maybe then watch this video. Okay, so this is a different way it's done. It's using cylinders. I'm actually going to make mine with basically boxes. Okay, I find it a little bit easier. So, so basically what you want to do is go to the next page. I think you have probably a space, I think, on the next page maybe. So when you go in here, click on to, go to rolling objects, and you are going to make an object roll as well. So we'll try to do that too. All right, there's an example code of what it will look like, rolling with slipping. We're going to just go to do without slipping. I'll try to do it all together. It might be a bit long, but I'll pause and try to do things. So there's some examples in here, but basically I want you to create an object that rolls like this and rolls along a surface. Okay, but we obviously have to make the wheel, and then we have to compound the objects, and then we have to then make it spin, and then eventually add the ground. Okay, so that's kind of where we're going with. All right, now, perhaps to make it a little bit easier, I'm just going to go to GlowScript. So I'll do the editing and creating my program there. Okay, now I'm in GlowScript, and I'm going to basically make a program called the rolling wheel. And so the first thing I'm going to do is just add a command, and we're just going to essentially set the background here. So I've added a comment of establishing the background. Then I'm going to basically make the scene so it's a certain width and height here. And then I'm going to create two objects, a couple objects here. First thing I guess we'll need to do is create an object called a ring. So if you're not sure what kind of objects you are available in VPython, just type in GlowScript objects. And then if that page over here will show you all the different sort of 3D objects that you can go to. Like there's the compound, which is making several objects, grouping them together. But we need to make the tire, and the tire is going to be basically a ring. So a ring is very similar to like the cylinder, except it's kind of like a donut and has a thickness to it. So there's the attributes. You've got the position vector where the center of the wheel is, the axes of which it points, the radius and thickness. So that's basically what we're going to do first is we're going to make a ring for the tire. So back to over here. Okay, so I've added a line to tire equals ring dot pause. So it's centered at the origin, a radius of 10. It's pointing out along the x-axis. I'm doing this purposely so you can see what happens here. And the color is orange. So if I run this, all right, hopefully you'll see it. There you go. You get the tire, but the problem is it's like if I kind of shift the orientation, it's kind of like in that direction. I don't want it in that plane. So this is to give you the idea. It's actually pointing to the x-axis, which is directly to the right. If I change this to be a 0, then 1 right here, and then 0, you're going to see that it's pointing along this axis. So it's pointing in that plane. So we don't want that. So the correct orientation, hopefully you'll figure out, is going to be a 0, 0, 1. So if I run this now, you should see that now I have a nice tire in here. Okay, I can also add a thickness to it. So I can change that thickness to 0.5 in here. So if I run that, you can see I can change the thickness of that wheel. So you can add that as an attribute as well. Okay, the next thing I'm going to do is make a spoke. And for a spoke, I'm going to basically use a box. We're just simply going to use a box here. And we're just going to point the box in the right direction. Okay, so that's how I'm going to simply do it. So back to over here. So my first spoke, that's really two spokes, is a box. Now you'll see the size is 20 because the diameter of the wheel is basically 10. And then I made the thickness of it 0.5, and I'm pointing it along the x-axis directly to the right. So now if I run the program, you should see a spoke this way. So for the next spoke, I'm just going to duplicate this line in here. All right, so I'll copy and paste that into the next line. I'll call it spoke 2, I guess. And then we're going to change just simply the axes. So if I change this from a 0 and bet this one to 1 along the y-axis and I run it, now I have a spoke that goes straight up. Let's try now to make the ones that go diagonally. So we'll call that spoke 3. All right, oops. Copy and paste that line. And we'll call that spoke 3. All right. And spoke 3, we're going to change that so it goes diagonal. And hopefully you can see this. I'm going to make this as 1, 1. So it's like 45 degrees. So if I run this, I now have a spoke that goes that way. And then the last spoke, and you guess what that would be. I'm simply going to call that spoke 4 and change the axes. And all I have to do is just change maybe the x component to be a -1. And now I get the other one. Okay, last piece I need to do is I need to add a point, P, and I'll just use a sphere. Okay, so now I have a point P, like a red sphere. And if I run it, hopefully you'll see it right over here on the right side. Okay, so the next step is we're going to basically compound the objects all together and make it as a wheel. Okay, so I'm going to call all of these objects compounded together wheel, and I'm going to use what's called the compound function. And inside that compound function, we're going to have square brackets. And we put in all the objects that we want. So I've listed the tire, the spokes, and then the point. I did spell that wrong in here. All right, and now if I press run, hopefully it doesn't show anything, but I now have an object that I can rotate. Okay, just to maybe point this out, I can use a scene pause function. There's my scene.pause function, and then if I, for example, type in a command like wheel.rotate, and I'll rotate it 1 radian, and then about the z-axis, and about the origin, which my wheel is all constructed, then you'll see if I run it, there's my original wheel, but if I click on the screen, you can see that it zoomed out a little bit, but it did rotate by basically a pi radians in the counterclockwise direction. Okay, so what we need to now do is basically start making a loop, but before we do the loop, we have to define some variables. So I don't need this at this point, or maybe I'll just comment it out for now. All right, we'll come back to that. And now what we need to do is define some variables. So we need to initialize or define theta. We'll just make it 0 initially. We'll make the angular velocity whatever you want. Maybe it's at rest initially. We'll have the angular acceleration, say 1 radian per second. And then we'll have the initialize the time at 0. Then maybe we want to run the code for 5 seconds. And we want the increment of time to be 1/100th of a second. So those are some of the things that we need to have in our loop. And now we're ready to basically start our loop. Okay, so we're going to use the while function. So while t is less than t max minus, say, dt. And then we're going to slow the animation down by using the rate function. And now these are things that you need to understand. Remember, we want to basically update the angular velocity of the rotating wheel. So we'll say omega equals omega plus alpha times dt. Then we need to update the angle. So theta equals theta plus omega times dt. All right, and then we need to then rotate the object. So a couple ways of doing that. You could basically use the rotate function. Like I could steal this over here. All right, whoops, let's just take this guy and put that over here. All right, and we can rotate it instead of 1, we'll say, now that's the tricky part. Maybe we don't need theta, we just want delta theta. So maybe I will just call this as d theta. Okay, let me just add a little bit of space in here. So instead of theta, we'll put d underscore theta, and then we'll just do omega times dt. So then really the angle is going to be rotated by the change of the angle, d theta. And then the axis is the same and the origin is that. And then we'll just need to update the time, t, say, plus equals dt. Now, hopefully, if I did everything right, I didn't make any errors, it'll rotate our wheel. Let's see. And there is our wheel rotating and getting faster and faster and faster. Voila. Okay. So the other way you could rotate the wheel would be not using the rotate function. So maybe I'll just comment this out. All right. And we'll just add in a line of theta equals theta plus d theta. All right. And then what we're going to do is, and this is not indented, but I'll indent that in a second here. And then comment it out. And then we're going to just use wheel dot axes equals vec. And then you could do cos theta, sine theta, and then 0. And that should also work. That's the second way of rotating it. All right, and not sure what's happening here. There it is. And there it is. The wheel is also rotating. So there's basically two ways to rotate it. Okay, just make sure you don't mix them up. If I'm using the rotate function, I just use the change of the angle. If I'm using the wheel.axes, it just basically relocates the axes of the wheel by using cosine and sine of the actual angle that it's at its new position. Okay, getting long, but maybe I can try to squeeze in the last part. How about we want to make this wheel roll along the ground? So let's add another object in here called the ground. So I've added this line called ground. It's just a box. It's down at -11. Why? Because the wheel is centered at 0, 0, and the bottom of the wheel is at 10, but I want it kind of sitting on top of the ground, and I know the thickness is already 1. So basically I kind of made it -11. All right, and then the size is 100 long, length and width. And so then if you kind of run it, you'll hopefully see that the wheel is over here. Now let's actually, we know that if we run it, the wheel's just like spinning in one spot. We actually want the wheel to rotate without slipping. Okay, so what we're going to do is we're going to relocate this wheel. Maybe we'll just move the position. Now we created the wheel over here. We can say, well, let's put wheel.pos.x at negative, say, or positive 50. So if I'm basically moving its x position to 50. So if I run it, you can see, oh, it's over here now. Now I run it, but I need it to roll to the left here. It's spinning, but it's not moving. So what do you do to make the wheel rotate? Well, we know how to rotate, sorry, how to make it translate. At what speed do you think it has to move at? So maybe I'll go over here and kind of talk a little bit about that. You may recall an important formula when you have something that's moving. Let's say this point is moving to the right at some velocity v. And then you know that the wheel is rotating at an angular velocity omega, and the wheel has a radius r. And I'm hoping that you might realize that if I look at this wheel here, right, this is the wheel on the ground here, that basically this wheel must be moving at such that v, the translational velocity, is the radius multiplied by the angular velocity. So we need to basically make the wheel move at that translational speed. So go over to our code here, and we need to go over here and add a little bit of lines in here. So we're going to add in a line. All right, I don't know where to put that. Maybe we'll put it underneath theta. And we're going to say v equals, now what's the radius of the wheel? The radius of the wheel is, well, 10, right? I mean, you could do, so basically 10, or you could put r, I guess, if you want, and then multiply by the angular velocity, which is w. So that's basically calculating the translational velocity of wheel, essentially using v equals r omega. Okay, then we just need to make the wheel translate in that correct direction, to the left. So we just need to change the wheel's position in the x direction. So the wheel's position is the wheel's position dot pos dot x, and then we're going to make it go v times dt, or actually just make it go times dt. That's delta x, right? That's, if you recall when we talked about that. So if I run it, hopefully, okay, we'll run properly. It's moving in the wrong direction. It's spinning clockwise and I'm moving it to the right. So hopefully you can figure that out. That's an easy fix. We're just going to simply change the wheel so that it moves to the left. So we'll just make this v negative because it is moving counterclockwise. So now if we run the program, hopefully, all right, now we should see a wheel that is rolling to the left and not slipping to the ground. All right, so hopefully that kind of makes sense on how we did that. All right, and you get an idea of how to make a wheel rotate and then how to make it roll. Now you can do like a little bit more complex. You can add, if you look at some of the code that's written up here, you could see, like, you could explore how would it look like when it's slipping and not slipping. And you can see that the other teacher who created this basically has a number line in here. And so you can see that when you run it, it actually has little tick marks, and you can see it actually moving along here, which is kind of nice to see. And this is actually slipping. Okay, so play around with the code. All right. Also, you should explore how to graph too as well. But I hope that this all helps and it makes sense how you can build a wheel and make it rotate. All right. And then also make it roll without slipping. All right. And that's it for this video.